Welcome to part 3 of my video help series for LaGuardia Community College's Topics in Astronomy lab entitled The Greenhouse Effect. In this part, we're going to be looking at climate change and how it depends on the concentration of greenhouse gases in Earth's atmosphere. In this part, we'll be looking first at the temperatures of Earth's atmosphere at different times in its recorded and less recorded history. We'll begin by going from no greenhouse gases, which was the state of affairs at the end of part 2, to the atmosphere as measured for 1750. This is measured not from contemporaneous recordings, but by looking at ice core data, tree rings, things like that. I've now configured the atmosphere in our simulator to reflect the state of affairs in 1750, and I'll let that start going, and we'll just wait a moment for the temperature to stabilize. As the temperature stabilizes, look again at the infrared photons. In part 2, we examined what happened when the greenhouse gases were switched off. Now that I've switched them back on again, you should see those infrared photons again engaging in that kind of unusual behavior that we noticed at the beginning of part 2. It appears that the global temperature in the simulator has now largely stabilized. It's jumping around by 1 to 2 degrees Fahrenheit, but it's remaining relatively consistent. So now it should be safe to record an answer to question number 7, what temperature does the atmosphere reach when conditions are set to 1750? I'll let you make that recording, and then I'll switch the atmosphere to how it appeared during the end of the last ice age, approximately 15,000 years ago. You'll notice that that nice verdant foreground has disappeared and it's been replaced by this wasteland, a combination of dirt and reflective ice in the background. And now what we'll see is that changing the atmosphere to these ice age conditions shows very different behavior for those infrared photons. And we'll see a change in the ambient temperature that reflects that switch. What we're waiting for now is for the temperature to stabilize. It's slowly ticking its way up and down, so this one could take a little bit before things finally equilibrate, and so we're just going to have to wait until we finally reach that stable temperature, and once we do have a stable temperature, that's the answer that you're going to record as your response to question number 8. What temperature did the simulated atmosphere reach this time? This time, of course, being the time of the ice age. It looks like we're more or less stable at this point, so you can go ahead and record a temperature. And then question number 9 is the last question that you'll need help for with the simulator itself. Question number 9 is asking you to fill in this table. We're going to look at the concentrations of the greenhouse gases in our model atmosphere at 3 different periods. The ice age has been filled in for you as an example. And if you look, you'll see that the numbers in this column here exactly reflect the concentration that's listed for this ice age atmosphere on the panel. CO2, 180 parts per million, methane, 0.38 parts per million, etc. So what you're going to do to start with is to record those conditions for 1750. So you'll take these measurements here and you'll copy them into this column. So carbon dioxide goes on that first row, etc. And then for the bottom row, for your temperature measurement, you're going to copy in your answer to number 7. So whichever answer or whichever number you wrote down as your answer to number 7 up here, you're going to copy that number into this bottom row of the 1750 table. And then you're going to go through the same exercise for today. Now remember, today is actually 2009 because this is a relatively old piece of software at this point. So the numbers that are recorded in the panel are appropriate for the atmosphere in the year 2009. That's what you're going to record in this column, and then you'll copy your answer from part 2 in question number 4 for your temperature in 2009. That's what you need the simulator for. Everything after this point is going to be done either using the internet or your own intelligence. The part for the internet is to fill in this last column here. What you want to do is you want to find the average global concentrations of the 3 greenhouse gases in the year 2019. You can use Google or DuckDuckGo or any search engine that you like in order to find those answers, and then also the global average temperature from that year. As you search for the global average temperature, be a little bit careful, because oftentimes you can see reports not of a global average temperature, but of what's called a temperature anomaly. So that tells you how different the temperature in 2019 was from the average from 1900 to 2000. So if you want to convert that temperature anomaly to a real temperature, you also need to know what the average temperature during that 20th century was. Sometimes you'll find a reputable source that will just give you a number in Celsius or Fahrenheit, and that's fine. Other times you might have to add the temperature anomaly to the average temperature from the 20th century to get a good answer for this last row. And then the last 2 questions are asking you to figure out what's going on as far as climate change goes. So look at your results in the table and what has been the general trend in greenhouse gases since the last ice age. And considering the results in the table, what do you think that's likely to mean for the future? So if the present trend continues, how do you expect the concentration of greenhouse gases to change in the future? And then what would that change in greenhouse gases mean for the future of global temperatures? And you should be able to answer those questions based on your answers to the lab so far. You may, for example, want to go back and refer to your answer to question number 6 from part 2, as well as to your reading materials for the section on greenhouse gases. Thank you for your attention. I hope this video has proved to be helpful, and I'll see you in class.